Carl McAvoy, and we're doing lesson 6 for Math 064, which is talking about perimeter and area, and a couple of other things that we might have in our greater than, less than. Let's talk about the idea of what perimeter is and what area is first. Perimeter is the distance around an object. The kind of shapes that we're going to be finding perimeter for are called polygons. Poly means many, so it could have many sides. The first thing, the smallest number of sides is 3, that's a triangle. And then we have 4-sided, which if we had, I know you can draw shapes on here, but I'm gonna not try that. So go with me here that this is a square. What would make this a square is that all sides would be equal. In math, to show that all sides are equal, that definitely looks like a rectangle and not a square. Let's see if I can fix that a little bit. Is that more square? I don't know. Let me erase that and draw something. I'm going to tell you that it looks a little different on my screen than it does on the computer. My screen looked a little more square than that, but let's go ahead. Now I've got the eraser. I don't want that. Let's go ahead and try something that looks a little more square. No. Looks a little more square on the screen. Up here it doesn't so much. It has the same sides. The length are all the same on a square. So how we show that is we put a tick mark in all 4 of those if we want to show that they're all the same. We use the word congruent. I'm not even going to write it down because it's not something you're going to be tested over. But just sometimes we say that all sides are congruent. That means that all sides are equal at the same length. But for our purposes, when I ask you something, I'll just tell you it's a square, and I'll remind you that a square has all sides the same. Then we have something that's definitely not the same on all sides, like this, where it's definitely longer than it is wider or something like that. That's called a rectangle. And in this case, the ends are the same, but then the lengths are the same but different. They're the same across from each other, and across from each other the same. So rectangles have 2 sides that are the same on the end and 2 sides that are the same down here, but they're not necessarily all the way the same all the way around. The other shape we're going to be working with is a 4-sided shape called a parallelogram. And the thing about a parallelogram is it looks like a rectangle that's been tilted a little bit, like pushed over to the side. And that's a parallelogram. Parallelograms also have equal sides. These 2 sides are the same, and these 2 sides are the same, but not necessarily, they could be different from side to side, but they're always across from each other, congruent across from each other, congruent across this way. There's another shape we're going to deal with. I'm going to erase the definition for perimeter, the distance around, so I can draw one more shape that I want to show you, and that is, it's called a trapezoid. It would be really nice on this smartboard to have spell check, because I'm really terrible at spelling, but I think I've got these words down. A trapezoid looks like a triangle with the tip cut off. And there's not necessarily any congruent sides here. They could be, but not necessarily, so I'm not going to mark those. what we have when we talk about a triangle, we have sometimes you'll see an imaginary dotted line going down the center. And I'm going to redraw this bigger than before because I want you to be able to see this pretty clearly. So let me draw a bigger triangle. I really would like to have nice big shapes here to work with. Okay, what we have in a triangle is an imaginary line. So usually it's drawn as a dotted line like that, and that's the height of a triangle. When we're talking about perimeter, which is just the distance around, the height doesn't mean anything. It's inside the triangle, so it's not part of going around the outside. We also have what we call in a triangle the base. We use the word base for a lot of different shapes. The base is what it's sitting on, so we have a base and a height of a triangle. For a square, we just have these are each called a side, right? And so if I wanted to do a special formula for square, I could say there's 4 sides, so 4 times a side. But I don't want to make special, I just want to say add all the sides for perimeter. We'll look at the formulas for areas in a little bit. A rectangle, we say this has a length, that's this, and a width, which is this. I could give you a special formula for perimeter of a rectangle also, but I don't want to because it just makes things more complicated. For a trapezoid, we have another one of those dotted lines because we also are concerned about the height of a trapezoid. But different from the other things, in the trapezoid we have a big base down here, we use a capital B, and we have a little base up here, so we use the lowercase b. So we're interested in the little base and the big base and the height when we're talking about area. But for perimeter, that height has nothing to do with it because we're just going to add up all the sides. And for a parallelogram, we also have the imaginary dotted line coming down the middle of it. And again, that's our height. Sometimes you'll see in books that instead of height, they call it altitude. Same thing. Altitude is how high it is. So height is okay or altitude is okay. I'm going to use height. And we also talk about the base of a parallelogram. Those are just some labels that we're going to see again. But for our purposes, for perimeter, we're just asking how big around is this thing? If I went all the way around it, how long can I walk? So those are the 5 shapes that you need to be able to work with. Square, rectangle, parallelogram, trapezoid, and triangle. So when you see those, you need to recognize what kind of shape they are. And then remember the term height. That's the dotted line, how tall it is. Doesn't have anything to do with the perimeter. And remember that we use the word base for triangle and trapezoids and parallelograms. We use that term base a lot. Okay, let's do a couple of perimeter problems. If I ask you to find the perimeter, all these I'm just asking for the perimeter. If I gave you something like this, hopefully you'd recognize that as a rectangle. I'm sorry that it's hard to write on these boards and make it look good. Let's say I told you this was 10 yards long and 7 yards wide, and I ask you to find the perimeter. Well, one of the mistakes that people sometimes make is they say perimeter would be 10 plus 7. Because that's what they're seeing. They're seeing a 10 and a 7. Add them all up, you get the perimeter. Remember, it's add all sides. So I would have to say this over here is also 7. Remember those lines that told us those were the same across from each other? And this up here would be 10, because it's also the same as across from it. That's what that tells us when they're across from each other, they're the same. So not just 10 plus 7, but another 10 and another 7 to get the perimeter. And the perimeter is going to be 10, 20, 34. And here's where we need to remind you that we need to put units on there. It's not just 34 floating out there in space, it's 34 yards, because that's what we were working with. So you need to put yards. That's called the unit. And when you're talking about a perimeter, if you wanted to put molding around the floor of the room that you're in, most of the rooms on this campus have a big wide strip of molding that go around the bottom. You would want to find the perimeter of the room and then put that around. It's just a length that goes, kind of wraps around the room. And we call it units. The units for perimeter are what we call linear. Some of you might have worked in construction before and you've gone to buy boards and you're looking at it's sold by the linear foot. So you've heard that term before. Some of you may never have encountered that. But it's out there. People use that terminology. So linear just means a straight line. So if I wanted to know, if I took this red line and I just laid it out straight, it'd just be one big long red line, then I could measure it to be 34 yards. So when we write linear yards, we don't show linear. It's just kind of understood that we're talking about linear yards. So we just write the unit yards. Whatever unit was given in the problem is what we have for the perimeter of that. Okay, so let's look at a perimeter of something different. When you look at something like, let's say, a triangle, sometimes you can have a triangle that has a right angle in it. Right angle has 90 degrees. Sometimes it looks a little differently. Triangles are all sort of different. But let's say for this problem that you were told that this was 20 centimeters. This one was 32 centimeters. And this one was 25 centimeters. If I ask you to find the perimeter, all you have to do for the perimeter is add up all the sides. And so you're saying 20. And it doesn't matter what order you add them up in, because remember the commutative property says you can change the order and now change the answer. 20 and 25 and 32 would just add up. You can add them up in a row, or you can add them up in your head, however you want to do. If you can't do it in your head, rewrite the problem vertically. Because I wrote it horizontally, which is harder to do in your head, but as long as you write it vertically, you should be fine. And that gives me 77. Then I have to put the units, and the units in this problem were cm, which is centimeters. In later classes, you'll talk more about units and what that means, but centimeters are a metric unit similar to our inches. It takes 2.5 centimeters to make an inch, so it's shorter than an inch. But it gives you the idea that's just a measurement, a unit of measurement. That's finding the perimeter of a triangle. Let's find the perimeter of something else. Let's look at a trapezoid. Trapezoid has a big base, a little base, two sides. And remember too, if I was talking about area, I would be interested in this thing in here. So I'm going to add that in when we write our stuff. So let's say this was somebody's tract of land, and they had 1,005 yards on this side. It's a big piece of land. But the top up here is 983 yards. And this is 990 yards. Let's make this the same, 990 yards over here. And the height of that land, if we're looking at that, is just 902 yards. When I go to find the perimeter of this, I'm not going to include the 902 yards because I'm just looking at the outer edge, or the distance around these sides. I can write this in vertical form right from the beginning because these are big numbers to do in my head. 983, 990. I said 990, but you saw what I did, and I wrote 990. Remember, everybody makes mistakes when they do math. Are you going back and checking your work to find those mistakes? Or are you getting an answer that doesn't make sense and you find that answer? It's just when you make a mistake and you never go back and check and you never stop to think logically, does this answer sound correct? That's when you don't catch them. If you don't catch them, that's a problem. But if you make a mistake, no big deal. You just fix it. Okay, going straight down, 3 plus 5 is 8. 9 and 9 is 18, plus 8 more would be 26. 3 9s are 27, plus 1 is 28. And 2 plus 1 is 3. The addition is not the main thing we're doing here because we've already worked on addition. So do your addition at your pace, however you do it. Don't worry about if you can't do all the addition in your head the way that I do. This answer is not complete because I haven't written the units on there. The perimeter, which we use a capital P to abbreviate, 3,868 yards. That would be the perimeter of this. P equals. We do the P equals because the perimeter equals 3,868 yards. So that's the basic idea of perimeter. I'm not going to do any more perimeter problems because it's really just an addition problem. Just remember that the dotted lines, those are imaginary lines. They're not part of your perimeter. Let's look at some more important things, which are the area formulas for these shapes. We'll start with the most easy one. A square can just be considered a rectangle, so I'm only going to talk about a rectangle. If I have a rectangle, remember a rectangle has a length and a width. So when I want to find the area, abbreviated with an A, I take the length times the width. But what is area? Because perimeter was the distance around, area is the space inside in 2 dimensions. So if I'm talking about the space inside this whole room, it's got length, it's got width, it's got height, that's not area. I'm talking about the space inside the floor, where we're just talking about, like if I was going to buy carpet, you know, how much area is there to cover the floor. So for this one I have length and I have width. So if I multiply length times width, I get the area. The rest of the formulas are a little harder. If you have a parallelogram, remember you have the height and you have the base. I wrote those words out before, but height, I can't do that. I was going to try to dot that line a little nicer. It's a dotted line. It's not a solid line. But the area for the parallelogram, I'm going to have to write that over. Whoops. I have to write that all over because it's just too sloppy. And this is important that you see what's happening here. I've got a parallelogram that's got 4 sides, and then it has a dotted line that's imaginary going down it, and that's the height, and this is the base. Hopefully your drawing is easier for you than it is on the smartboard. If I want to find the area of a parallelogram, again I abbreviate area with A, and I multiply the base times the height. Base times height. It's instead of the 2 sides, it's the height in the middle. We don't use that height for perimeter, but we do use it for area. If I have a triangle, remember in a triangle we also have the dotted line. height, and we also have the base. Now the triangle formula would be nice if we'd already had fractions, because a lot of times people say 1/2 times base times height, and we haven't dealt with fractions, so we're going to write the formula where we don't need to use a fraction. It's base times height just like a parallelogram. It's base times height, but unlike a parallelogram, once you get that, you divide by 2. So it's base times height divided by 2. Why is that? Well, because every triangle is half of a parallelogram. If we continued this parallelogram over, this triangle over, and kind of doubled it, we'd have a parallelogram. So that triangle is half a parallelogram. And all triangles are half a parallelogram. That's why we just take the base times height that we have here, but we cut it in half because we're missing half our parallelogram. That really is what happened. We're just missing half of it, so we just divide it by 2. Okay, and the other one is the trapezoid. Remember, for a trapezoid, you have a little base and a big base, and also the height. So you need all 3 of those to make your area formula. Always I should be putting A equals that. And so area equals a little bit more complicated. You've got to take your big base and your little base and find the average. And we talked about we'll talk about finding the average when we're dividing, but I think we can divide by 2 already. It's just cutting something in half. Big base plus the little base, that answer divided by 2. That whole thing then multiplied times height. So a little complicated, huh? Big base plus little base divided by 2 times height. But we're going to see it's not so bad when we go through there. Okay, so let's have all those formulas written down. You're going to be asked to know those. Again, I didn't say this at the beginning because I've been saying it through the other videos, but in order to get the most out of this video, you should print off the practice worksheet first, and as you go through, take your notes, be looking at your practice worksheet and making sure that you're getting all your questions about that sheet answered as you go through. Making little notations to yourself and trying the problems on there. Pause the video and try something. Okay, so let's start with the easiest one, rectangle. And let's say that I gave you a rectangle that was 3 inches by 6 inches. And ask you, find the perimeter and find the area. Well, perimeters just add up all the sides. So you would say 6 plus 3 plus 6 plus 3 adds up to 18. And then you have to put on the inches, because that's the unit we were dealing with. Those are linear inches, just straight out inches. Okay, what if I ask you to find the area for that? Let me give myself a little bit more room. The area is not the distance around, it's the space inside that area in 2 dimensions, not the depth. But if it was just a flat polygon like we have here, that's what we're talking about. Let me show you something about a 6 by 3. If I was to cut this into 3 equal pieces, these aren't exactly going to be equal because I'm freehanding it, but I'm cutting it into 3 because that was 3 inches, so 1 inch, 2 inch, 3 inches, and then cut it into 6 equal parts. Because that was 6 inches up here. So I have 6 inches along the one way and 3 inches along the other way. What does that give me inside there? It gives me a bunch of squares. And I could actually count those squares to see what the answer is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares inside that rectangle. The way I get that is the formula is length times width. So instead of having to draw that and count it, I can just say length 6 times width 3 gives me 18. This is a pretty terrible example because we got 18 for the perimeter and the area, and that doesn't usually happen very often, but it happened here. But the difference is we have a different unit. Remember, perimeter had linear units, but area has square units. If you've ever gone to Home Depot or heard somebody else talking about buying carpeting, they buy it by the square yard because it covers 2 dimensions, a length and a width on the floor. It's not just a strip like molding, but it's 2-dimensional. You buy paint, it tells you how many square feet that gallon will cover, and so you can figure out the square feet on your walls and see if you have enough paint in 1 gallon or 2 gallons. And so we talk about square units, and you can write out the word square units if you want, or you can write it this way. We have inches, and squared means to the 2nd power. So we have 18 square inches, or inches squared. What we don't want to do, this is bad. You do not want to write 18 square inches. That's not good. Because that says 18 to the 2nd power. It's not. It's the inches that are to the 2nd power. The 2nd power, when you're in math, means square. So remember, if you want to write it abbreviated, don't want to write the word out square inches, then write it inches to the 2nd power, not the 2 first. But it's a little different than how you say it, right? So the squares come from the actual picture. You can see that there's squares in there. There's 18 of those square units in there. And all area problems have the square units. Even circles have squares, and then when you're talking about that. So let me just do one more rectangle that doesn't come out to be the same. It doesn't usually come out to be the same. So let's say instead of that I have 7 meters by 3 meters. And I ask you to find the perimeter. You would do 3 plus 7 plus 3 plus 7, or 20. And what would the units be? Just meters, because the perimeter is always linear. Then if you want to find the area, you would take length times width. 7 times 3 is 21, but what would the units be? The units would be, we're talking about meters, so it would be meters squared, because it makes a square inside there. That's what gives us 21 meters squared. So area is always a unit to the 2nd power. Perimeter is always just your unit. That's called a linear unit. Okay, I think we got that. Let's try a problem finding the perimeter and area of a triangle. This is the order that they show up on your practice worksheet. The first one is a rectangle. No, the first one's a parallelogram, sorry. We just did one like number 4 on your practice sheet, a rectangle. Now we're doing this as number 2 on your worksheet. Let me give you some dimensions. Remember, this height is imaginary, but we write it in to tell you what that is. So let's say this is 10 miles, and this is 18 miles, and these are 12 miles on each side. Ask asking you first to find the perimeter and then to find the area. So we want to do two things with this. The perimeter, the formula is add all sides. So all I'm going to do to find the perimeter is do 12 plus 12 plus 18. I am not adding 10 because 10 is not one of the sides. It's just the height of the thing. So 8, 9, 10, 11, 12. 1, 2, 3, 4. I get 42. That's the perimeter, but not quite because I haven't included the unit, which would be just the miles. Nothing to the second power. When you're talking about perimeter, it's linear units just to the first power. Okay, now I'm going to do the area of a triangle. The formula for the area of a triangle that I told you was base times height, and that answer divided by 2. I know we haven't really talked about division yet, but division by 2 you probably can do because it's just cutting something half of what you have. So let's see how we do on that. The area would be then the base. What's our base? It's 18 times the height, which is 10. And whatever we get, we're going to divide that by 2. All right? Remember the shortcut for multiplying by 10? All you have to do is take the 18 and add a 0. And then we have to cut 180 into 2. 180 to 18, let's just take the 18. 18 cut in half would be 9. So 180 cut in half would be 90. It's not 90 though, it's 90 something. It's got to have the unit on it to make sense. What's the unit for area going to be here? It's going to be miles to the second power. Okay, so sorry about the dividing by 2. We'll talk more about division in the next thing, but I think you can get it. Dividing by 2, just cut the number in half from whatever it is you started with. Okay. All right, let's talk about a trapezoid. I'm going to write the formula for a trapezoid up here. It's hard. It's the hardest one. It's a big base plus a little base, whatever you get, divided by 2. And that whole answer times the height. So that's pretty complicated, but we'll see. It's not so bad once you get started. So let's say that I have 10 feet, and up here I've got 8 feet, and on the side I've got 9 feet, and then I also have, remember, this imaginary line coming down, and that's going to be, I'll make that 8 feet also. Alright, so what you're going to be asked to do is to find the perimeter and the area of these two things. The perimeter is the easy part because it's just adding up the numbers that are on the outside, height not having anything to do with it. So going around the outside we have 8 and 9, 10 and 9 again. And add all those up to get the perimeter. 9 and 8 is 17, plus 9 is 26, 2 plus 1 is 3, so the perimeter is 36, what? Feet, because it's just whatever unit you started off with is the unit that you're going to have. It's linear feet. Now let's talk about the area. What I have to do for the area first is to add the big base and the little base together. So I'm going to do that first. That's going to be 10 plus 8. Then I'm going to divide that by 2. And then, because that's part of the formula, then when I'm finished with all that stuff, I'm going to multiply it times the height, which happens to also be 8. So inside the parentheses, 10 plus 8 is 18. And then 18 divided by 2. We just did something like that. So 18 divided by 2 is 9. And 9 times 8 is 72. So we have 72 for our area, except that it's not just 72, it's 72 with units attached, which would be, hopefully you're saying by now, feet to the second power. Whatever our unit is, it's to the second power. That's a hard one. We're going to do another one of those before we finish today, just so you have a second example. You're not going to be doing a lot. You have one problem on your practice sheet and probably one on your in-class, but it's something that you'll work more on as you go into Math 90. You'll get a chance to work with those. But let's do one more example of that you'll have to do. This is like number 1 on your worksheet, and that's a parallelogram. I'm going to say that this is pretty poorly drawn, but 19 meters over here and 17 meters here and 12 meters here. What I'm asking you to find is the perimeter and the area. The perimeter is add up all sides. Remember that 12 is inside, has nothing to do with the sides, so that's going to be 17 plus 19 plus 17 plus 19. 9 and 7 is 16 plus 7 more is 23, plus 9 more is 32. You don't have to be able to do all that in your head. Make use your fingers and make marks off to the side, whatever. 3, 4, 5, 6, 7. I have 72 for my perimeter. 72 is not my answer until I do what? Until I put the unit on it, which the unit here was meters. Okay. Next thing I'm going to do is find the area, and the formula for the area of a parallelogram is nice and easy. It's base times height. So you really have 2 easy formulas and 2 harder formulas that you're dealing with for area. But all the perimeter ones are easy. Add up all the sides, that's it. So the base for our problem would be 17. That's what it's sitting on. That's our base. The height is given inside, that dotted line is 12, so 17 times 12 would be our area. I don't know what that is, so I'm going to do that off to the side. 2 times 7 is 14. 2 times 1 is 2, plus 1 is 3. Now I'm multiplying by 10, so I put the 0 in there. 1 times 7 and 1 times 1. Adding straight down, 4, 10, carry that 1. I get 204. 204 is not the correct answer until you put your units on there. And the units would be meters squared. Okay, those are the 4 shapes. The perimeter is not bad, but the area is a little trickier. Remember, all area units are always to the second power. I'm going to change a little bit on your practice sheet because I have something in there that doesn't come out nicely and I want it to. So I don't really want to look at that too. I can change it right now while we're all looking. I'm going to change this to be 14 because I want it to come out to be nice. So you're going to be asked to find the perimeter and area for each shape, the perimeter and the area. The lines are down here given for you. For the parallelogram, when you see this, it doesn't show all the sides, but you know that opposite sides are equal or congruent, So that would be 16 over there, and that would be 15 up there. Here you have all three sides for your perimeter, and you have the base and the height, which you need for your area. You have length and width for your rectangle, and for your and your trapezoid, you have the big base and the little base and the height and the two sides. So it's a lot to look at, but I think you'll be ready for all four of those if you watch the video and pause it and take a look. The next part of this homework assignment is asking you to do a matching. Let's just pick one to match. Let's pick number 8. The answer to these kinds of problems always has units to the first power or linear units. And then you look over here and say, which one of those? Well, it's either perimeter or area. The linear units is perimeter, so that would be an A right here in this box. All right, the formula to find the area of a rectangle, the formula to find the area of a triangle, you have to be able to match over here. Just put the letter that matches over here, and you might use some of these more than once. So it's a matching one that you can answer having watched the video. And the next section asks you to compare using greater than, less than, greater than, equal to, and so forth. So let me just define all of that, and then we'll go back and do some word problems using perimeter and area. Less than points left. Less than points left. Less left. If it's an arrow pointing left, that means less than. People get confused which is less, which is greater than. Greater than points to the right. Less than to the left, greater than to the right. You hear greater than and less than in your everyday life. People bring it up. I got less than you. I get less pay than you do. Less than to the left. He worked a greater number of hours than I did. Greater than to the right. People talk about less than and greater than, right? Also, we talk about less than or equal to. And that looks like a less than symbol with an equal to part there. And so, I don't know if you're bowlers, but if you know anything about bowling, the best score you can get in bowling is 300. If you throw a strike, which means you knock down all 10 pins first try, if you throw all strikes to the whole game, you get 300. Best game you can get. So if you're talking about a bowling score, we would say your bowling score is going to be less than or equal to 300. It could be equal to 300 if you had a perfect game, but it's probably going to be less than that for the rest of us, right? So less than or equal to would show something that could be at the most 300, but probably less than that. Okay, if you want to go to high school, you have to be less than 21. Less than 21. As soon as you turn 21, you're done. But if you want to buy alcohol, then you can be greater than or equal to 21. As soon as you're 21, you could be exactly 21, you're golden, right? So that's greater than or equal to. And that has the equal to part. If you're looking at a stadium that you built and you can put 10,000 people in it, then you say the capacity of the stadium is less than or equal to 10,000. You can't put more than 10,000 in there. A classroom has to be maybe the most you can put in a classroom is 50. So it could be exactly 50, it could be less than, it could be less than or equal to. Sometimes on this campus we say you can't teach a class unless you have at least 15 people. So that means the students in the class, there could be exactly 15 or you could have greater than. So it's greater than or equal to. Students are greater than or equal to 15. So that if it can be exact or greater than or exact or less than, then we talk about it being greater than, equal to, or less than, equal to. But notice that less, whether it has the equal to part or not, is always pointing to the left, and greater is always pointing to the right. And of course we have equal signs. We've been talking about equivalent symbols already, and that's just this. There's also something that's approximately, sometimes we don't know exactly. It's like, how many people were there today? Oh, I don't know, about 20. You didn't really count, but it looks like about 20. That's this. Little wavy lines, approximately. Math is really an exact science, but a lot of time in math, we just round or estimate. And then it's approximately. It's not exactly that. So sometimes you see that symbol in there too. So what I want you to be able to do is to compare numbers using these different symbols. And so let's write up some symbols or some problems. We can only use, let's say each of these can only be used one time. So we have to find the best use because we can only use them once. I'm going to write down, there's 5 of them, I'm going to write down 5 things. So number 1, I'm going to say 750 compared to 345. Number 2, I'm going to say, what's something that we all... something that we all, a number that we all know, something that's greater than or less than. Senior citizens are something to 65. Number 3, I'm going to do 10 plus 9. Number 4, I'm going to do 2,120 to 4,650. And number 5, this may or may not be true, but teachers make maybe not true, I don't know, but we're going to put it in there and see. So we want to use each one of these one time. Let's start off by finding the one where we could use the equal sign, because that seems the most straightforward to me. Which of these are equal? Well, these two, number 1, these two things are not equal. Senior citizens don't all equal exactly 65. But 10 plus 9 always equals 19. So I could use that one right there, and I'm done with that symbol. What about 750 and 345? 750 is definitely greater than 345, so I could use this symbol. But it's also, I could say it's greater than or equal to also. So that's not a great one to use. What about number 2? Senior citizens are something to 65. If you're 65, you are a senior citizen. So you could be exactly 65, but you could be more than 65. So the best choice for this one would be greater than equal to. And so we've used that one. Now I can go back to number 1 and say, well, 750 is definitely not less than. So it has to be that I use the greater than symbol for that one. And you have 5 of these on your worksheet in different orders, but you want to go through and similarly think about that. Teachers make either $75,000 or maybe less, a lot less in some cases. 2,120 is less than 4,650, but I think it's better to say this is definitely less than. And this one, they could make exactly 75,000, but they might make less. And again, that number I just picked out of the air, so it could be a totally different number. But that's how I would fill that in. Those ones where you have the words, those are the greater than, equal to, or less than, equal to ones that will help you do that. So just want you to use those symbols so that you kind of get to know them. I gotta hurry on through this. Let's take a look at number 16, the word problem. How many square feet of vinyl floor covering will be needed to cover the floor of a room which is 10 by 18? Well, just because it asks for square feet should be a red flag to you that we're talking about area, because perimeter is linear feet, area is square feet. And so I have this room, and the room is, that's right, I have trouble writing on this thing, I forget. I'm going to close this. The room is 10 by 18. So I have a room that's 18 feet by 10 feet. And I want to cover this whole space inside in 2 dimensions, no depth, but length and width. And so I want to find the area for that. So you have to first decide, am I looking for area or perimeter? That's an area problem, and the formula for a rectangle is just length times width. So you would do 18 times 10. Get 180 or 18 a lot in these examples. And then I would want you to have the correct unit on the end, which would be feet. Okay, so just finding the area of that. Let's take a look at the next problem. Number 17, a room is 12 foot square. If molding cost 80 cents per linear foot, what will it cost to put molding around the ceiling of the room? If it's a 12 foot square, that means that it's 12 feet on every side. A square has all sides the same. So it just tells you that it's 12 here, 12 here, 12 here, 12 here, and these are all feet. So I'm going to put molding around. I'm not going to fill in the floor. I'm just going to go around the edge. So it's perimeter that I'm looking for. So I'm going to add 12 4 times, and that gives me 48, and that is feet. But let's read this question again. 48 feet is how long it would take me to go around. But the question is, if it costs 80 cents per linear foot, what's it going to cost to put molding around the ceiling of the room? So after I get my 48 feet, what do I need to do? My answer is going to be in cents. I know that if you were working this problem later on in math, you'd change that into dollars. We're just going to look at it in cents. So I'm going to multiply by 80 because it's 80 cents for every single foot that I buy. That's 0. 8 times 8 is 64. Carry your 6. 8 times 4 is 32. Plus 6 is 38. So it's 3,040 cents. And if you want to know what that is in dollars, it would be $38.40. But I don't really care about that. We're just trying to get you to know to find the perimeter and then also multiply by 80 to get the amount of cents that you'd get. So it's not dollars, it's just cents, which is $38.40. Okay, let's take a look at the last problem. A shopping center designs a triangular sign 10 foot across its base and 8 foot high. If the materials for the sign cost $3 a square foot, what will the materials cost to complete the sign? Again, once they talk about square units of any kind, we're set because we know it's an area. It's a triangle and it has a height of 8 and a base of 10. So let's see what that would look like. You should try these problems before you watch it. It's 8 feet high and it's 10 feet on the base. So we're going to multiply base times height because the formula for the area of a triangle is base times height, the whole thing divided by 2. So we're going to get 10 times 8, which is 80, and then we're going to divide that by 2, and 80 cut in half would be 40. And that is square feet because that is the unit for area, feet squared. But back in this problem, it told me that it cost $3 for a square foot of material. So I'm going to take that 40 and I'm going to multiply it times 3. And that tells me $120 to make that sign if it's $3 per square foot and we have 40 square feet. So it'd be $120 to build that sign. Okay. So the word problems are good in here, but I really just want you to be thinking about the perimeter and area. Remember about square units versus linear units. Always include your units. So people say, well, I got it right, I just didn't put the units on. The units are really important. All your Math 90 teachers are going to think that when you go into Math 90, you're going to want to put the units on there. So get in the habit of using those and practice that. I said I would do one more trapezoid problem because trapezoids are kind of tricky. So I'm going to do that. Let's say I have 12 feet. And up here I have 6 feet. And over here I've got 9 feet. And 7 feet. What I'm going to do is write the formula up here. Big base plus little base divided by 2, the whole thing multiplied by height. So if you haven't yet, shut the video off and try this and then turn it back on and see if you got it right. So our big base is 12 and our little base is 6. Oh, I keep getting 18. 18 must be a lucky number for me today. And then the height is 7. 12 plus 6 is 18. 18 divided by 2 is 9. And 9 times 7 is 63. It's not just 63, it's 63 with a unit attached, and that unit is feet squared. And the perimeter of this will just be add up all the sides, the length of the sides. Okay, you guys are ready to try your perimeter and area practice sheet if you haven't gone through it already. If you need more practice, ask your instructor for some worksheets for more practice on perimeter and area. All right, we'll see you next time. Have a great day.